In this lesson, we're going to take a look at the real-world Pythagorean theorem applications. Let's take a minute to review the Pythagorean theorem formula. We have a squared plus b squared is equal to c squared. Where a and b are the legs, the two sides that make up that 90-degree angle on the triangle, and where c is a hypotenuse, that is always the longest side, which is across from that 90-degree angle. So how do I apply the Pythagorean theorem to real-world applications? Number one, find the hypotenuse of a triangle that has a height of 4 feet and a width of 8 feet. What's really important when solving these real-world applications is to draw yourself a picture of what this would look like. All right, so here's my right triangle. All right, and let's label our A and our B. Remember, those are the two sides that make up the right angle. And then our C is always that distance that's across from, or the side that's across from that right angle. All right, so we're looking for the hypotenuse, so we're looking for the C. It has a height of 4, and it has a width of 8. So now let's plug this into the Pythagorean theorem and solve. So remember, we have a squared plus b squared is equal to c squared. 4 squared plus 8 squared is equal to c squared. So you'll have 80 is equal to c squared. Remember, we don't want the c squared, we want just c, so we're going to take a square root of that. And you'll have 8.944 and so forth. So we're just going to round this to the nearest tenth. So we're going to say C is equal to 8.9. So what is, find the hypotenuse? It's going to be 8.9 then feet. All right, in our next example, it says the bottom of the ladder must be placed 3 feet from the building. The ladder is 7 feet long. How far above the ground does the ladder touch the wall? So let's say that this is the side of our wall, and let's then have this be our ladder coming down the side, and then this would be our distance then from the wall here. All right, so it says that the ladder must be 3 feet from the building. So this would be our 3 feet, because that was the building over here, and then the ladder is 7 feet long. So remember, the ladder is the thing that is leaning up against this building or the wall. And so now we're looking for this distance right here from how far up it goes. So let's make this our A, this our B, and this our C, our hypotenuse. So we'll plug it in. A squared plus B squared is equal to C squared. So I don't know A squared, but I have 3 squared is equal to 7 squared. So A squared plus 9 is equal to then 49. And we'll continue solving. And now remember, I don't want to have A squared. I want A, so A is going to be equal to, it'd be 6.3245. So let's just say 6.2. So the height of this building right here is 6.2 feet, or the ladder will be 6.2 feet from the ground on that building. All right, so Padre has a rectangular garden measuring 7 meters by 2 meters that he wants to split diagonally from corner to corner using a fence. How long does this fence have to be? All right, so again, let's go ahead and we're going to draw this rectangular garden. And he says it measures 7 meters by 2 meters, and he wants to split it diagonally from corner to corner. So he's going to split it from diagonally this way. Now notice what that makes. It makes these two right triangles. He wants to know then how long does this fence need to be, and his fence is going to be this part that goes down the middle diagonally of the of this rectangle. All right, so, and let's just put the 2 meters over here because we know that those are the same side. So now we know that we have an A, we have a B, and then we have our hypotenuse for C. So that's what we're looking for, is that C. So we're going to plug this into the Pythagorean theorem. We'll have A squared plus 7 squared is going to be equal to c squared. So we will have then 2 squared plus 7 squared is 53 is equal to then c squared. All right, and again, we do not want c squared, we want c. So we'll take the square root then of 53, and we'll have 7.28. So let's just, so 7.28, and that gets longer. Let's just round this to the nearest tenth, which would be then 7.3. So it would be 7.3 meters. So from here to here, you'd have 7.3 meters. All right, in our last example, it says Micaiah walks 6 miles north, then 3 miles east. How far is she from her starting point? All right, so remember, we on a map we'd have this is north, this is south, this is east, and this is west. So we need to make sure that we know these directions here. All right, so Micaiah is going to start right down here, and she's going to walk 6 miles north. All right, and then she's going to walk 3 miles east. We're going to the east. This right triangle, and we're looking for our diagonal, which is the hypotenuse. So let's make this our A, our B, and our C. So 6 squared plus 3 squared is equal to c squared. And that's going to give us 45 is equal to c squared. And we do not want c squared, we want the square root of that. So our c is going to be equal to 6.708 something. So let's just say 6.7. And so if the distance from here to here is going to be 6.7 miles. So in this lesson, we took a look at applying the Pythagorean theorem in real-world applications.